Okay, good afternoon, everyone, and welcome to grade 9 coding. Excuse me. It is the 16th of July today, and we are going to be looking at conditionals in B. So, you've heard me say this conditionals word before, and today we're going to have an opportunity to see exactly what it is about and start using it in some of our code. For those of you watching on YouTube that don't know me, my name is Mr. Paul de Klerk, and I am the senior phase coding teacher here at STEM Digital. I've been teaching coding with them since, I think, April or May. I'm not sure. But I thoroughly enjoy computers and computer coding, so I'm grateful for the opportunity to share that passion with somebody else. Students that are willing to learn about it. Okay, if you are watching on YouTube, you can head down to the video description box below to find links to register for our lessons. Then you can come and join us here in the live lessons where you'll have access to the chat box and you can come and ask questions or receive the resources and the links that we share with you. Without further ado, let me continue. So here we have a quote that says, "People who know how to code is in a catalytic spot. They can make things happen." This was said by Clive Thompson, the author of Coding, The Making of a New Tribe and the Remaking of the World. So this wasn't, I'm not sure if this comes out of this book. I haven't had the privilege of reading it yet, but what I did read was a blog post where he was the guest blogger on that blog, Clive Thompson. And just by looking at the name of his book and this statement that he makes here, I fully agree. A very, very clear, easy, simple to understand example is the one that we are a part of now. Look at the way we're doing education. We are remaking and we have remade and we are busy improving on that remaking, but the world is being remade with regards to education because we are now no longer in a situation where we're safe if we are in classrooms or if we have too close contact with other people. So what we need to do then is to still find a way to connect. And I think that's an important thing to remember in these difficult times, that even though you're not in direct contact with people, you can still connect with people, right? And you have to connect with people. You shouldn't lose that connection with people. But we are now not only connecting with each other, but we are also connecting to education, and we are continuing with education in a different way. And basically, people like us that can code, people like you that are learning how to code, we're going to be the ones in this economy that's going to make things happen, right? So let's have a look at some of these terms that we need to know about. The first one there is conditionals. Conditionals are if-else logic statements that change the way that code is executed, okay? Excuse me. So I'm not going to continue on that for too long because you'll see it now in a second. Next one we have here is variables. So variables are the placeholders for information that can change. And what makes that awesome is you can write an entire program without having the variables, without knowing what the value for the variables will be, and you can still create the program and just add the variables in later. So we're first going to complete Minecraft puzzle 12 to 14, and then we're going to look at the conditionals in B. 2 to 5. Now, as you know, I'm not limited to any of these numbers, so I just adjust my planning if I need to. Right, I'm going to jump onto the coding screen in order to share the lesson with you. So for those of you that are new, or for those watching on the YouTube video, if you keep the link open in your address bar after we finish the Zoom call, you can come back to this page here, which is a section that I created under my code.org account for you to work on. So you can come back to these first puzzles and do them. We've done them. They just don't show that they've been done because this is when code.org changed over to the new 2020 version. Okay. This is where we're at. So we're already on lesson 10, right? So, I mean, if you really want to come and do these, you're new or you're just catching up on the YouTube channel, you can do that. So if you're in the lesson now, you just need to copy this. You can open this link, and if you click on it, it should open your browser. And then if it opens your web browser, then you can see in front of you what I see in front of me. Okay. And if you are on the YouTube channel, you can type that, which I've just highlighted there on the top, but you have to type it exactly the way it is, right? studio.code.org/s/express-2020/stage/10/puzzle/11. And that's going to get you exactly onto this page. And right, so I'm just going to, oh no, it's fine. We did 10 yesterday. I just want to jump back to confirm what I'm looking at here. Okay, so this is the one we did where we created a bridge to cross over for the lava. Now, the next one is still using that same idea, right? And I think I left you with this homework yesterday. It's possible. But this is our first introduction into conditionals right here. This little block here. That is a conditional logic statement. If there is lava ahead, then we want you to do something. If there is no lava ahead, then we don't want you to do something. You just continue with the code that is coming next. So if we take this out of this little repeat block of ours, then we can see it says destroy block if lava place cobblestone. Now let's take the conditional out and check what would happen, right? So we can add a move forward. So let's run that and see. Okay, so there it works. And that's beautifully done. We don't have any issues, right? Now, the moment you repeat this, though, it becomes a bit of a story. Because now, even if there isn't lava there, as you can see, we will continue to place cobblestone there. And we're going to bump our heads, and we're going to break it, and we're going to place it, and this will just continue until the loop runs out. Okay. So that is, and you can see now, Alex is not in a mood for this anymore, right? So the way we combat that is the moment you place a statement in the code, like this one, place cobblestone, the code will try to execute that. Doesn't matter what's happening here. There are no conditions that it is taking into account. It's just going to try and execute, point blank, done and dusted. Because we told it to do so, right? By virtue of placing that statement there, by virtue of placing that block there. That is why it'll just continue to try and do that in the sequence that we've placed it. So for us to ensure that this doesn't become a problem, I'm going to take it out of this loop and I'm going to show you just the sequence. Right? Remember, I always say, create your sequences and then then drop them into loops so that you can check the sequence is working. That's a problem-solving workflow we have there. Identify the problem, create a solution, test the solution. Then we see it works, we adjust it by adding it into the repeat. We see it doesn't work, we can adjust it before we put it in here. Once it's here, it's difficult to see. The only times we can start off with a straight repeat is if we're just drawing a single line or we're doing a square or a basic shape, because then it's very obvious to identify mistakes. Right, so now you can see he's checking for the lava, right? So now we did that once. So what I want to do is place this into a repeat. So you can see the second one we know there isn't lava there. So he's not, or she's not placing the cobblestone. If you look over here, you can see the yellow. If the lava, now it goes to that. Now, if the lava, it skips right there. It skips this do part. Okay. So what we just need to do is count how many times this needs to happen. So we need to see lava is hiding beneath some of these blocks. You will need to cover up before moving forward. An if command, add a move forward, the correct place to mine these blocks. Okay, so it's not saying, excuse me, how much we need to do. So we're just going to go 1, 2, 3, 4, 5, 6, 7, 8. Let's set this to 8. But I think we only have to go to the end of the iron. We'll find out soon enough. So there you can see, each time the block is broken, the code is checking. If there is lava, it's going to place a cobblestone. If there is no lava, it's not going to place the cobblestone. It'll skip that and just go on to whatever's next. Does that make sense? Are you happy with that? Type a yes in the chat box if I can continue. Okay. Awesome. So we're going to continue there. Onto this one. Right. So I think this is the one I left you with for homework. Now things are getting tricky. Mine 3 redstone, but don't fall in the lava. Use an if command to place cobblestone everywhere you uncover blocks. So we only have 14 blocks to do this. We need these redstone blocks, but we only need 3 of them. So there are a few ways you can go about this, okay? If I have to think now, it's just going to be easier for me to show you my thinking, and then you can compare that to your thinking. Right. So my thinking is that if I check this, I see a pattern there. Move forward, break, check, place, turn left, move forward, go. Same thing there, same thing there. This one we just need to be careful with the extra move forwards. So in my opinion, I'm going to start by creating my sequence, which will say move forward, then we want to destroy the block in front of us. So we do that. And we see there's lava there, right? That's why everything's up. So what we're going to do is say, if there is lava ahead, then you need to place cobblestone. After you've done that, we want you to move forward and turn left. Great. So now we can see that this and that looks exactly the same. So all we need to do is repeat this 3 times because there are 3 of these patterns that we want to make. Again, checking for lava. If there isn't any lava, the cobblestone doesn't get placed. So you could have also turned here and placed cobblestone here to cross the lava. You could have come down here to break this one and then break that one. You could have just come straight here, broken this one, go in there, break that one. There isn't a correct or an incorrect way to do this. The only reason why I did it the way that I did it was because I wanted to look for the pattern that I can most easily recognize and use that pattern in a loop. Because I know if I can do that, I'm going to limit the amount of blocks that I'm using. Okay. So if you have another form of thinking, you think you can do it differently. I know one of my students the last time did it in something like 7 or 6 blocks, but she just went in here and randomly broke a bunch of stuff in a repeated 20 times, and just broke random stuff until she eventually mined those 3. So in my opinion, this was the clearest pattern for me that still doesn't make the code look like somebody accidentally found the solution, right? You can see that this has been thought through and applied accordingly. So does this make sense? Are you happy with this? Can we continue on to the next puzzle? Okay, there's a link. Great job. You've gathered lots of resources and built a modest home. Now lay rail from the edge of the map to the door of your house. So there's a new one here, place rail. And it only gives us an option to choose that. And if we run it, you can see what happens there under Alex, right? So we need to place the rail from the edge of this map up to there, that block there. Okay. If you place the correct type of rail here next to this redstone torch, it'll actually be powered and automatically push the minecart. So the first thing we need to do is obviously get Alex aligned to move in the correct direction, which will be a turn right. Now we're going to 1, 2, 3, 4, 5, 6, 7. Okay, let's see. Again, now this one we can just start because it's such an easy sequence. So you can easily test this. Okay, so I don't like that idea, right? So what I want to do is make this one 6 and perhaps place that rail there and then do it this way. Let's see how that looks. We're testing, so it's fine. Okay. Now that that's there, you can see what I've decided to do is instead of placing the rail and then moving forward, 1, 2, 3, 4, 5, 6, 7, because I need to place a rail 7 times. But if I have placed rail and then move forward and I repeat this 7 times, Alex ends up off of the path. So the way we have it now, we're back on the path and we can just repeat this here. Not 6 times, but 2. And that should work. Awesome. We have, however, now placed one inside the door, but it doesn't seem to be a problem. So if you don't want that one there, then you're going to have to adjust the code. Let's look at the other way to do this, right? So that we can adjust the code accordingly. So this was the way that I did it now. It gives you 8 blocks used and it creates a situation where you're placing a rail there. Let's see if we can't tidy this up, even though we might be using the full 9 blocks there. So we obviously want to turn right here. Then I'm too lazy to count today, so I'm just going to test it. I think there's a shorter way to do this, to tell you the honest truth. Yes. What's going to happen if we repeat this? No, not 6 times, twice. Oh, look at that. Perfect. So 5 blocks, in fact. 1, 2, 3, 4, 5. Yes. Compared to 1, 2, 3, 4, 5, 6, 7. Okay. So this is the thing though. With this one, I had a certain set way of thinking that I wanted to approach this. I've done these puzzles before, but it's been a long time ago. And obviously just knowing code doesn't necessarily show you the best way to do the puzzle, right? It does help me to fix the code if I made a mistake or to improve on the code once I have a solution, but it doesn't necessarily help me to find the solution for the specific puzzle. So I had a certain way of thinking here, which was that if I placed this rail, then I go past here, which is not something that I wanted. But I didn't even count these ones. If I counted these ones, I would have seen, okay, if I don't place this one and I place it after I've turned to make this block form a part of this line, then these two lines are exactly the same. And that's what you see there. So are you happy with this? Can we continue? This puzzle isn't a puzzle. It's a free play area. You can see if you walk any direction, there's a bunch of stuff there. So I'm going to drop this link for you. And remember the other day I said, when we had that quote from Mark Zuckerberg that said, coding is like any other sport. You can know the rules, but if you don't do it, you're not going to get good. Okay? You only get good by playing it. So this is one of those puzzles. If you really want to check if you understand code, let Alex or Steve or whoever you chose to play with move one so that it zooms out. Now you can see this entire area. While this is here, plan what you want to do. Obviously taking into account these blocks that you have available. Okay, but you can place from bedrock to gold ore, emerald ore, TNT. So there's a lot of stuff that you can do. So plan out what you want to do, what you need to chop off, where you need to build bridges, and how you want to go about this, and create something here, right? You don't have to be extremely creative to do that. Anything simplistic is fine. The exercise is not to see how amazing the thing is that you're creating so that we can compare that to others and judge it. Not at all. The aim is to see if I want to create something, be it cool and massive or be it cool and small, do I have enough understanding of how these blocks work, how they get put together, how they function, in order for me to create something on my own here without any guidance from this telling me what to do. Okay? So it's not something we're going to do in class, but it is, however, something that if you would like to, you can send me a screenshot. I would actually love to see what you guys decide to make here. But yes, you can send me a screenshot, not only of the play area with your finished creation, but also with the of the workspace that will share the code with me that you created to do this with. Okay. Awesome. So now we're going to continue on to the next lesson. Okay. So just to avoid confusion, I'm going to type this or share the link again. It says the cloud is blocking the view. There could be a flower under this cloud. If there is a flower, the bee will need to collect nectar once. So it's telling us that if there is a flower, you will only need to do it once, not more than that. Okay? If there's not a flower, the bee should do nothing. Take a look at the code below. What do you think will happen after you click run? The bee will move to the cloud and try to get nectar no matter what. The bee will move to the cloud and only try to get nectar if there is a flower underneath. The bee will move to the cloud and then do nothing no matter what. I don't know. So this says move forward 3 times. I don't know is not an option. So we count 1, 2, 3. Okay. So the bee is going to be right on top of this. Let's hope it's not some animal that's going to eat the bee that's hiding there. Then we use an if statement, a conditional statement, stating if at a flower, right, you have to get the nectar. So what is happening here is this get nectar will only run if there is a flower. If there is no flower, the get nectar will not run. That is really important because if you try to execute the get nectar block on a space on your work, on your play area that doesn't have anything on it, you get an error here at the top telling you, listen, I cannot harvest that nectar from here, or it's too far away or something like that. So this if really helps us out there. So in your opinion, what is the answer here? Type it to me in the chat box. A, B, or C? Definitely not D. We have 1 vote for C. Anyone else want to chime in here? Okay. I think it's going to be B. Perfect. Correct. B was the answer. Let's just check that again. The bee will move to the cloud and only try to get nectar if there is a flower underneath. Remember, this if at flower is very similar to saying check for a flower. So it's saying move there. When you get there, check for a flower. If there's a flower, then you do something. If there's no flower, then you do nothing. Okay. More clouds. Check underneath every cloud to see if it is hiding a flower before you get nectar. If there is a flower underneath the cloud, the bee will need to get nectar once. Remember, not all clouds hide the same thing. So we can't just say move, turn, move, collect, collect. We have to say check, because what if this cloud isn't even hiding a flower? Maybe it's hiding a piece of corn or something like that. So what we have to do here is move twice. Then we want to turn right. Then we're going to move again. Now, well, we can do it this way, or we can just repeat this. No, we can't repeat this. I'm lying. Sorry. So lying. What we need to do here is move forward, and if at a flower, get nectar. There we go. That we can repeat twice. Now, if you run it again, you'll see sometimes it changes. Now there's a flower, there isn't one. Okay, so that's why you can't just place a get nectar there. Because if we looked at the first one, it just seemed like, just say get nectar. It's going to be shorter and the flowers are there. But you'll see each time you run it, it's different. Sometimes the flowers are not there. And in some of the future puzzles to come, it can be one of a few different things that is hidden away, that you don't know what it is. Okay. So who of you are happy with this? Can we continue? Okay. I've given a bit of time, but there's only quizzes yes coming through, so I'm just going to continue. All right. You can only collect nectar from flowers, but you can check any space to see if there is a flower. If there is a flower, under any of these clouds, the bee will need to collect nectar once. We're limited to 5 blocks, but we need to do 1, 2, 3, 4, 5, 6, 7 blocks. But let's see. So where we want to start is to move forward, obviously, to be on top of that. And then we want to check if at a flower, we want the bee to get the nectar. And this we want to repeat. One, two, three, four, five, six, 7 times. Okay. Again, we could do this because we were checking, not just getting nectar. But if you check, they can change that pattern of what or how the flowers are available to us, as you can see now. And it doesn't matter, it does not affect us. Okay, so in the previous puzzle, we saw that using these conditionals help us when we do not know what is coming next. But they also have another application where they help us out a lot. And that is not only for when we do not know what is coming next, but for when we cannot identify a set pattern, right? That's going to be probably more important than just knowing, or more often used than just having a situation where you don't know what is coming. Okay, sorry, I'm trying to think about a few things at the same time here. So you will more often be faced with a situation where the pattern is difficult to identify rather than not knowing what is under those clouds. Okay. But the solution for both is the same. So if the solution is the same, then this one should be quite easy for us to do. So we're going to move forward and we're going to check if we're at the flower, then we want to get nectar. 1, 2, 3, 4, 5, 6, 7. Right. So there you can see we've now used 5 blocks to solve this one. Not because we didn't know what is under the cloud, but because there wasn't a set pattern. So taking a conditional and combining it with a repeat like we did now, it creates a situation where you can have more freedom to repeat code, even though there isn't necessarily a pattern, right? There is some pattern here, but in the code, there's pattern because that and that is repeating. So it's just as well you put that in here 7 times. But what I meant to say is that this you can't use on its own. It has to be into the conditional. Okay. Right. So what I would like is, if you would be willing to, type in the chat box for me what I should be doing here. We need to collect all of the nectar in as few blocks as possible. Any ideas from anyone there? What block should I be using? Okay. I'll go with this. It's going to be our last one for today. So we're going to move forward. Obviously, we want to check if we had a flower, we want to get nectar. So there's the solution for this first one. Awesome. That's good. So now what we want to do is we're going to repeat this. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, just to make sure that we've got it all covered. Then we're going to turn left, move forward, turn left again. And then we repeat this 6 times. 2 times, not 6 times, 2 times. Let's see if this works. Now it doesn't, we need one more move forward here. Okay. So this one is your homework. Now I just want to make honey. Some of these clouds might have honeycombs under them, but be sure to check if a honeycomb is hiding behind each cloud. If there is a honeycomb, the bee will only need to make honey once. Right. So tomorrow we're going to continue with conditionals in B, puzzle 5 to 11. And I think we're obviously going to start with puzzle 6 because we finished puzzle 5 today. Thank you for being here. If you have any questions or you'd like to share your code with me, especially that last Minecraft one, right? So I said now homework on 2 different things. So remember, that last Minecraft puzzle, this number 14. Oh, come on. That isn't homework. That is for you to go and practice and experiment on, and for you to share it with me if you'd like to do that. I couldn't copy it out of the chat box. Let me just go back. I'm just going to jump back to that screen quickly. Sorry, give me a second, because I can only copy it when I'm on there. This one. So I just want to see here. So there I just typed for fun and practice. That's this puzzle here. Okay. If you want to share that with me, that's fine. There are no expectations there. The other one is this one. This one would be good if you did this one. For homework. Because it's going to help you to practice the things that we are actually doing at the moment. Okay. Then if you'd like to share that with me, you can share it to me here. And you can search for us on Africa Teen Geeks on Facebook, Instagram, and Twitter. And then have a great day. Thank you for being here. See you tomorrow. Bye-bye.